So in chapter 4, we take a look at angles, and then we're going to be doing the sine, cosine, tangent, all that SOHCAHTOA stuff. We're going to be working our way up to the unit circle, and it's really, really an important chapter. It's foundational for the majority of the stuff that we're going to do this second half of the chapter, or of the course, sorry. And the first half of the course, a lot of the chapters were kind of just different things we were looking at. We had one chapter on polynomials, another chapter on exponential functions, just kind of different things we were looking at. In this half of the course, a lot of the material is going to build on itself. And so this chapter 4, I just really can't emphasize enough how important it is to understand it well, because it's the foundation of everything else that we're going to be doing. Not quite everything, but most of the things that we're going to be doing in the second half of the course. And so first we just need to make sure that we understand angles, and the different way we measure them, either with degrees or radians. So angles measure the amount of rotation. They have a starting or initial side and an ending or terminal side. We look at the amount of rotation between those two different sides. Now when we sketch angles, usually we do them in standard position, where we start the angle at the right side of the x-axis, make that its initial side. And then positive angles actually rotate counterclockwise, and negative angles are the ones that go clockwise. If that seems kind of strange, it's because positive angles are rotating towards the positive y coordinates up here, and the negative angles are rotating towards the negative y coordinates down there. But positive is actually counterclockwise, negative is actually clockwise. And hopefully you remember the quadrants. We label the different parts of the coordinate plane here as quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And so let's say we want to sketch these angles and determine the quadrant of the terminal side. And so, of course, if we're in degrees, hopefully we'll all remember degrees. A full circle, of course, is 360 degrees. So if we rotate all the way around, that would be 360 degrees. And so then just a half a circle is 180. And then straight up, a right angle, of course, is 90 degrees. And so then straight down, 180 plus another 90 is 270. And so these are going to kind of be our bench posts. When we're sketching angles, we're not going to use like protractors like you might have done in geometry, try to get a really accurate angle, anything like that. We're just going to try to do a rough sketch. As long as it's in the right quadrant, we're going to be happy. Okay, so we're just going to use these as kind of our bench posts, our markers to tell us, are we in quadrant 1 or quadrant 2, based on whether we're less than 90 or more than 90, that kind of thing. And so, of course, 100 degrees would be just past 90 degrees. And so we're always going to start here on the right side of the x-axis, and then we're going to rotate just more than 90 degrees. And so we're going to be at 100 degrees there. Now, when we sketch an angle, though, we have to show the rotation that we're doing, because there's different angles that this could represent. Right? Can you picture multiple angles that start here and end there? It's not just 100 degrees. So 100 degrees, I have to draw this little curvy arrow to show that that's the angle that I'm drawing, because we also could have rotated backwards. We could have had a negative angle that rotated that way. Or maybe we had an angle where we went in 3 or 4 full circles before we landed there. Maybe there was a lot more rotation going on before we ended here. So we have to draw this little curvy arrow to show exactly, again, we're measuring the rotation. So we have to show exactly what amount of rotation and what direction of rotation we've done. Okay. So now negative 200 degrees, so the positive angle, again, we rotated this way towards positive y values, actually counterclockwise. So the negative angle, we still start in the same place. We're still going to start on the right side of the x-axis. But now instead of going towards positive y values, we're going to go towards negative y values. Now we're actually going to go clockwise. Okay. And so if we're going backwards, this is negative 90 and then negative 180. And then we don't quite reach negative 270. All right, so if we were going backwards, these just flip here. This would become negative 90 degrees. This would become negative 180. That would be roughly the same. And now this is negative 270 right there. And so we're between negative 180 and negative 270. And so we're somewhere roughly there. Okay, and so let's see, forgot to say the quadrant. These are actually both quadrant 2, aren't they? A lot of times quadrants, they use Roman numerals, but you don't have to. You can just use a regular number. So both of those angles, the terminal side where it ended up was in quadrant 2. Okay. All right, now these angles are going to have a lot more rotation. These are going to rotate more than a full circle because you've got more than 360 degrees. And so you want to kind of separate it out. You want to say, okay, I start with 360 degrees, and then how much extra rotation do I have to do? That's an extra 40 degrees. So we're going to start here, and then we're going to rotate in a full circle. And then 40 degrees, that's not much extra left. That's just going to be somewhere around there. So my angle looks something like that. Okay. And then 450 degrees. Let's see. Oops, I forgot that this one was negative, didn't I? Let's scratch that out there. That's important, huh? This was, I missed that little negative there. This was negative 360 plus negative 40 degrees. Okay, so let's start here. And then let's go backwards a full circle. If we go backwards a full circle, we're there. And then backwards 40 degrees. Now we land right there. Sorry about that. Pay attention to whether your angles are negative or positive here. So with this negative 400 degrees, I actually land in quadrant 4 there. Go backwards a full circle, and then an extra negative 40 degrees. Okay. And then this one, I do the full circle plus an extra 90 degrees. And this one is a positive angle, so this one, again, either way, I start in the same place. It's just the direction of rotation. Negative, I needed to go clockwise. I needed to go this direction. Positive, I need to go this direction. So I'm going to go a full circle, and the 90 degrees is straight up, so I'm going to land right there. Okay, now we're asking about the quadrant of its terminal side. Well, this one's not in a quadrant, right? This one's right between quadrant 1 and quadrant 2. There's actually a funny word for angles like this. They're called quadrantal. If you've got an angle that lands between two different quadrants, it's called quadrantal. All right, so that's degrees. That's probably the first way of measuring angles that you ever learned. It's actually not the way that we use, the way that we measure angles in calculus, because degrees is completely arbitrary, right? Have you ever thought about that? Like who decided that 360 degrees was a full circle? Why? Why not 460? Why not 500? Why not 1,000? Who decided 360 degrees is a full circle and why? It's just kind of arbitrary. Somebody decided. That's the system that we've been working with. I mean, it works kind of nicely. 360 has a lot of factors. So there's a lot of ways to break up 360 into smaller portions evenly. You know, it's similar to the number of days in a year. Might be some connections there, but it's just arbitrary. Right? And so it doesn't work that well in calculus. It gets pretty messy if you try to do calculus with angles and degrees. And so we have another way of measuring angles where there's an actual real definition of the angle, not just an arbitrary decision. So what we looked at is we said, okay, the angle that we rotate is related to what we call the arc length, the amount of curve along the circle here. Okay, so if we take a particular circle, if you know, it depends on the radius, depends on how big the circle is. Well, but if we looked at a particular circle, if you tell me how big of an angle you rotate, I'll know how big this arc length is, this distance around the circle that you've traveled. Or the other way around, if you tell me how big the arc length is, if you tell me how far around the circle you've traveled, I can tell you what angle you've rotated. There's a relationship there. And so that's where we get radians. We look at this relationship between the arc length and the radius. We do have to say how big is the circle. Well, this ratio of the arc length and the radius gives us this angle in radians. Right? And then it's actually based on a specific formula. It's actually based on something. It's not just an arbitrary system. Okay, so let's start to figure out what some radian angles are going to look like. So we know in degrees that a full circle is 360. Well, what about radians? Okay, well, if we're looking at a full circle, there would be another word for arc length. If it's a full circle, we wouldn't just call it the arc length. If we travel in a full circle, that length, that distance would be called circumference. Okay, so then let's use this formula here. So theta is arc length over radius. Well, the arc length is circumference. We know that in general circumference, the formula is 2 pi r, either pi times diameter or 2 pi r. So then radius, we can just say r. So then what happens, those r's just cancel out, and so we get 2 pi. So that means that 360 degrees equals 2 pi. Okay, so now let's try to do some sketching with radian angles then. And so just like we had kind of these bench posts for degrees, we're going to need them for radians. So we know that a full circle is 2 pi. Well, if a full circle is 2 pi, how much would just be a half a circle? Full circle is 2 pi, half a circle, half of 2 pi is just 1 pi. And so we can use that kind of thinking to figure out all these different bench posts around the circle. So full circle is 2 pi, so half of 2 pi is 1 pi. So we've got 1 pi here is half a circle. Well, then straight up, that's half of 1 pi. So 1 pi is over here at 180 degrees. And so 90 degrees, that's halfway to that. Halfway to 180 is 90. Halfway to 1 pi is pi over 2. Pi over 2, of course, is the same thing as half a pi. Well, 270 degrees, how do we get 3 pi over 2 for 270 degrees? Well, this would be 1 pi, 180, plus half a pi, plus 90. 180 plus 90, 270. 1 pi plus half a pi gives you 3 pi over 2. 3 pi over 2, of course, is 1.5 pi. Okay, so instead of our benchmarks being 90, 180, 270, 360 in degrees, in radians, it's half a pi, 1 pi, 1.5 pi's, 2 pi. So our pi over 2 pi, 3 pi over 2, and 2 pi. So we're going to use these bench posts to sketch these radian angles. Again, all we're going to need is, as long as it's in the right quadrant, we're not going to, get out a protractor and figure out, is it, closer to this side or that side? It's not super important for us. We just want to know what quadrant is it in, because that's going to be what's important once we start doing sine, cosine, tangent, the unit circle, all that kind of thing. All right, so here's the key. Take your radian angles and make them mixed numbers. So this is 1 3/5 pi. So that means, of course, I'm still going to start here. We're always going to start on the right side of the x-axis. That means I know it's going to be more than 1 pi, but less than 2 pi. So I'm going to go past 1 pi, but I'm not going to get to 2 pi. It has to either be in quadrants 3 or 4. Okay? The question is which one? More than 1 pi, less than 2 pi, but are we in quadrant 3 and quadrant 4? Well, what's the dividing line in radians? In degrees, we'd be looking at, is it less than 270 or more than 270? In radians, we need to look at, is it less than 1.5 or is it more than 1.5? Well, let's think about 3/5. Compare 3/5 and a half. Well, 3/5, of course, is more than 1/2. So we are going to go more than 1.5 pi here. We're a little bit more, not much, right? 3/5 is just a little bit more than half. So 1 3/5 is just a little bit more than 1.5. So we're just barely going to be into quadrant 4 here. And so that's our angle. Okay. Negative angles in radians work the same way as degrees. We're just going to rotate backwards. Okay. So we're going to start here, rotate backwards. Well, we're just rotating pi over 5. That's just like 1/5. This is negative 1/5 of a pi. Well, negative 1/5 pi, that's not very much, right? So just like we did with degrees, where we said that 270 would be the same thing as negative 90, we can say that this right here would be negative pi over 2, or negative 1/2 of a pi. Okay? Well, we're only going negative 1/5. 1/5 is not very much. 1/5 is less than a half. This is a pretty small angle in radians, okay, because it's less than a half. So we're going to rotate backwards. We don't get to rotate past a half. We're rotating less, the amount of rotation is less than a half. So we're not going to get to go past this here. We're just going to be doing this small little angle, something like that. Okay. So about 7 pi over 2. So that's going to be 3.5 pi. Okay. Now, here's something to be careful about, something that people get really confused with radians. So this is a large angle. This is going to be more than a full circle. Make sure that you're clear how many full circles you're doing, though. You're only doing one full circle. This is 2 pi plus 1.5 pi's. Just like with degrees, we separated out the 360. We said after the 360, how much more rotation do we have to do? Well, here we're going to separate out 2 pi. Now, this is what people will get confused on when they're going too fast, though. People will think that that's 3 full circles and then a little bit more. It's not 3 full circles, right? Remember, this is one of the weird things about radians is that 1 pi is only half a circle. 2 pi is 1 circle. 1 circle is 2 pi's. Half a circle is 1 pi, right? So you want to split out the 2 pi and say the 2 pi makes me go in a full circle. And then I go 1.5 pi's. So I go half a pi, 1 pi, 1.5 pi, and I land right there. So keep that straight. 2 pi for a full circle. 1 pi is only half a circle. Okay, so we get that quadrantal angle there. All right, now what about this? 2.1? Where'd the pi go? Right? You might have thought all radian angles have a pi in them, but they don't. You can actually have a radian angle that doesn't have a pi. The way that you know something is a radian angle is not that it has a pi in it, it's just that it doesn't have a degree symbol on it. If it's an angle in degrees, it's going to have that degree symbol on it. If it's an angle and it doesn't have a degree symbol on it, it is radians. There's no like symbol for radians. Like there's no, inches you can put like 2 hash marks next to it, or you can put IN. There's nothing like that that we typically do for radians. We just don't put a degree symbol on it. Okay. So what the heck is this 2.1 here? Well, here's the key. How much is pi? We know what pi is, right? Pi is about 3.14. Let's just say about 3. Usually that's enough. Okay, so if pi is about 3, 2 pi would be about 6. Pi over 2, or half a pi, would be about 1.5. And then 3 pi over 2, or 1.5 pi, we'd have 1 plus half a pi, 3 plus 1.5, so about 4.5. Okay, so if we're working with just regular numbers without pi's, these are going to be our bench posts we're going to use instead of 90, 180, 270, 360, or pi over 2 pi, 3 pi over 2, 2 pi. We're going to think roughly 1.5, 3, 4.5, 6. Of course, those are approximations. It is about 3.14, 6.28, so on. Okay, but 2.1, well, that's between 1.5 and 3. So we need to have this angle in quadrant 2 here. And then the angle 5. Well, the angle 5, that's more than 4.5, but less than 6. And so we're going to have an angle here in quadrant 4. All right, so this is by far the most important thing from this lesson here. So I have several problems that I want you to try. Radian angles are going to be super, super important in this class and in AP Calculus, or any calculus class that you take. You really need to know radian angles well. So go ahead and practice sketching these radian angles. Again, just as long as you're in the right quadrant, you're okay. Use these bench posts here. Use these to figure out what quadrant it's going to be in. Go ahead and try sketching number 6 through 10. Sketch those angles for me. Right, you can check those answers there. Make sure your angles are in the correct quadrant. All right. Remember, when you're at 1/6 pi, you have not done a full circle yet. You need 2 pi's for a full circle. Okay. So number 7 was more than a full circle. We did a full circle, and then it was between a half and 1. 2/3 is bigger than a half, but less than 1. Okay. The negative, we just have to rotate backwards. So we rotate -1/2, -1, -1.5. And then we land right there. 7 was a little bit more than a full circle. 2 pi is about 6. So we have to rotate a full circle about 6 and then an extra 1. So we rotate the full circle about 6 and then 1. It's less than the 1.5 right there. Straight up would have been 1.5. Okay? And then when we do negative, again, it just reverses. So this is about negative 1.5. This is about negative 3. And this is about negative 4.5. And so negative 4 is somewhere in the second quadrant there. All right, so it's really important that you can sketch these radian angles just as radians, that you start to get comfortable with radians really well. But sometimes we do want to convert angles back and forth. You should not be trying to sketch these by converting these angles to degrees, but sometimes we do want to convert them. And the relationship that we use, so we started out with knowing that 360 degrees equals 2 pi. That's the kind of basic relationship between degrees and radians. But we simplify that down a little bit and use the relationship that then 1 pi would equal 180. And that's the relationship we use for converting here. And so this, since pi equals 180 degrees, we're just multiplying by a funny looking 1. This fraction equals 1, so we're allowed to multiply by it. Right? And so it just depends on whether you want to cancel out degrees or end up in degrees, whether you want to cancel out radians or end up in radians. So whatever you want to cancel out needs to go in the denominator. So for this first problem here, since I want to cancel out degrees, I want to change it from degrees to radians. I put the degrees in the denominator. If I put degrees down here, the degrees will cancel. And I want to end up in radians, so I put the radians in the numerator. Okay, and so of course we can cancel out these zeros here, and then 6 goes into 18 3 times, and so we get pi over 3. Okay. Now if I want to go the other way, so this one I want to cancel out the radians, so I'll put the pi down here so those pi's can cancel out, and I want to end up in degrees, so I put the degrees in the numerator there. So these pi's cancel out, and then 3 would go into 18 16, or sorry, 6 times. 3 goes into 18 6 times, so 3 goes into 180 60 times. And then I do 4 times 60, and I get 240 degrees. Okay, so why don't you do a couple of these problems real quick here. Convert 210 degrees to radians, and convert pi over 4 radians to degrees. And you can check your answers here. Should have had 7 pi over 6 for number 3 and 45 degrees for number 4. And notice for number 4, you could probably figure that out just kind of by thinking about it. So we know that pi is 180 degrees, is the straight angle here. So pi over 4 means to take pi, to take that straight angle and divide it into 4 pieces. Pi divided by 4. Take pi, straight angle, 180 degrees, divide it into 4 pieces. And pi over 4 is the angle that you take to get to the first border between those pieces right there. Okay? Well, that's splitting it right down the middle. Well, if you know the angle that splits right down the middle between 0 and 90 degrees, just like we know 90 degrees is straight up, the angle that kind of splits right down the middle we're often kind of familiar with is 45 degrees. So it should kind of make sense then that pi over 4, pi divided by 4 is 45 degrees.